Is it possible to find two numbers whose sum is equal to 1 and whose product is also equal to 1? At first, this may seem impossible. For example, 1 plus 1 is equal to 2, while 1 multiplied by 1 is equal to 1. So, the product is correct, but the sum is not. Let us try another example. If we choose 1/2 and 1/2, their sum is equal to 1. However, their product is 1/4 instead of 1. It seems that such two numbers do not exist. Let us find it out. Let the two numbers be x and y. Since their sum is equal to 1, we can write our first equation as x plus y is equal to 1. Since their product is also equal to 1, our second equation is x multiplied by y is equal to 1. Our goal is to solve this system of equations. Subtracting x from both sides gives y is equal to 1 minus x. We now substitute this expression into the second equation to get x times 1 minus x equals 1. Expanding the brackets gives x minus x squared is equal to 1. Rearranging the equation by moving every term to one side gives x squared minus x plus 1 is equal to 0. We have now obtained a quadratic equation in x. This quadratic equation cannot be factorized using ordinary integer factors. Therefore, we use the quadratic formula. Here, the coefficient of x squared is 1, the coefficient of x is minus 1, and the constant term is 1. Substitute these values into the quadratic formula like this. We get 1 plus or minus square root of 1 minus 4 divided by 2. Simplifying inside the square root gives the square root of minus 3. Since the square root of a negative number is not a real number, we must introduce the imaginary unit I, where I squared is equal to minus 1. Therefore, the square root of minus 3 becomes I multiplied by the square root of 3. Hence, the two possible values of x are 1 plus or minus I multiplied by the square root of 3, all divided by 2. Now let us find the corresponding values of y by substituting the value of x here. First, substitute the value of x containing the positive imaginary part. We get y equals 1 minus I multiplied by the square root of 3, all divided by 2. Next, substitute the second value of x, which contains the negative imaginary part. This gives us y equals 1 plus I multiplied by the square root of 3, all divided by 2. So, these are the two required numbers. Let us verify them. Adding these two numbers, the positive imaginary term and the negative imaginary term cancel each other, leaving only 1 plus 1 or 2.